Okay, if you're going to look to set this problem up, okay, it tells you if there's two possible solutions, write the answers as a list, the first one comma the second one. Okay, and when I sketch my triangle, I'm going to sketch it this way. I'm going to put whatever my known angle is right here. So my known angle is 23 degrees, and it's angle B. So I'm going to call this B. I now have a side BC and a side CA. Okay, so I know that the vertex that's shared by both of these remaining sides is C. So that means here's where C goes. C is that hinge point. So here's BC is 20 and CA is 33. Okay, so based on the rule that we just talked about, my longer of the two sides is opposite the given angle, so how many different triangles can I have here? If I tried to hinge this back and meet, I'd have a side of 33 opposite 23 degrees and a side of 20 opposite an obtuse angle. Cannot happen. So this one I know is a scenario where there's only one triangle. Okay. So if I label this A, what I can do is I can find my information for this problem. I have a known ratio. My known ratio are the B's. Okay. So the first thing that I can find, I have a known side. I can find the angle opposite that known side. So the first thing I'm looking for is my unknown angle A. So I'm still going to start with that in the numerator of my equation. So since A is embedded in the sine ratio, I begin with that. Sine of A over the side opposite it, 20, is equal to the known ratio. Start with the sine on top, sine of 23 over the side opposite it, 33. Now notice this exactly flipped what we worked on the first time. Right, the first one had the length, the side on top, the sine of an angle on the denominator. This one's the reverse. And this one's a little bit harder to solve. Your calculator doesn't solve for variables embedded in trig ratios. At least.
Does it matter like which one you put on top?
It won't matter, but I always put my unknown on top because it makes it easier to work with the fraction. If you did 20 over sine of A equals 33 over sine 23, whatever one you start with on the left, you have to start with the same piece on the top of the right. But then you'd have to cross multiply those, and then you'd undo it. You'd have to undo the multiplication, and it's going to wind up being like just one extra step. So if you set it up in this way, it just saves you from having to do one extra step. Okay, so this one you are going to set up by hand. So here I'm going to multiply both sides by 20. That gets my unknown, my variable, alone on one side. And I can go ahead and calculate the sine of A is equal to, and I can calculate sine of 23, I'll put a decimal in there, divided by 33 times 20. So I get my ratio, 0.3 or 0.2368. Okay, so I have the sine of A is equal to 0.3 or 0.2368. And this is what we looked at in section 8.3. Okay, in order to find an unknown angle, you can take an inverse trig ratio. So in this case, the inverse sine of this ratio is going to be angle A. So that's again where the inverses come into play. And so you can now take the inverse on your calculator. The inverse is located right here, diamond Y, of this ratio. I highlight the ratio and hit enter. I get 13.70 for my angle. So 13.70 is angle A. And now, in order to find side AB, which is also lowercase c, I need to know what angle C is, so I'm going to do the same thing we did with the other law of sines problems. Take 180 minus the two known angles, 23 minus the angle I just calculated, 13.7. So I get 143.3 for this angle C, even though there's no spot where I need to put it. And so my final piece of information to find is AB. I'm going to go ahead and start with my unknown in the top of my fraction. So AB over the sine of the angle opposite it, which was 143.3. And that's equal to my known ratio. I'm still going to go back to that known one. Since my AB is the side length, I'm going to start with the side on top, 33, over the sine of the angle opposite that, 23. Now, because my variable, my unknown, is a side length here, it's not embedded in a trig ratio. I can use the solve feature for this if I want to. I'm going to go ahead and just continue doing this one by hand. If I multiply both sides by the sine of 143.3, I can finish my final calculation here. 33 divided by the sine of 23, all times the sine of, and I'm just going to highlight my exact answer. Again, anytime you're doing calculations, use exact answers. Okay? Highlight the values from your calculator. Don't enter rounded answers. You're going to be off by some decimals if you do. Once I get my solution here, I get 50.47, and that would be my side length here. Okay, now, when I double check to make sure that these are consistent, the two shorter sides do add up to 53, which is greater than my longest side, so that's consistent. My longest side is opposite my greatest angle. My shortest side is opposite my smallest angle. Again, all my consistencies hold true. Those would be my solutions.